opportunities in Scotland's zero-emission ecosystem. We're running this event today with the Rail Cluster Projects running it, and we're running it in collaboration with Transport Scotland, the Hydrogen Accelerator at the University of St Andrews, Alkala Energy and Michelin Scotland Innovation Park. I'm personally really excited about this event and hearing all about hydrogen in the rail sector and its wider application in Scotland. Just before we go on, would it be possible for everybody just to double check that your mics are muted? I'm getting a wee bit of background noise, and your videos are off would be brilliant too. As with most of our events now, this one will be recorded and a link will be sent out to you after today. You can find previous events recordings on our Rail Cluster webpage if you haven't had a look already. I'd encourage you to take a wee look and look back on previous events that we've recorded. Just in case, for those who don't know me, a very quick script, a wee summary about me. I'm Shona Clive, I'm project lead for the Rail Cluster Builder project. I work with the team at Scottish Engineering. I'm also chair of Women in Rail and a member of Women in Transport. My previous roles with Babcock in the rail business, and I've worked in the rail sector for 25 years now. The rail cluster, just a tiny bit of background about the rail cluster, in case people don't know about it. The Rail Cluster project is an 18-month project jointly funded by Scottish Enterprise and the European Regional Development Fund. We're also directly supported by Transport Scotland. We've several aims, but in summary, our key purpose is to connect SMEs in the engineering and manufacturing sectors in Scotland, looking to diversify into rail or grow their presence in the sector. And we help connect or facilitate links with the rail market in Scotland, so linking SMEs with companies like Network Rail, ScotRail, Tier 1s, rolling stock manufacturers, and the wider supply chain. We also are very much about raising awareness of the opportunities across the Scottish rail sector and beyond. The context of the Rail Cluster project is the Rail Decarbonisation Action Plan, which I know our first guest speaker, Bill Reeve, will, from Transport Scotland, will speak more about. The aim of the Rail Decarbonisation Action Plan is to deliver carbon neutral rail transport by 2035 and make Scotland a leader in creating a net zero emission passenger railway. Just a little bit more about the rail cluster. The cluster continues to grow in numbers, which is really positive. We're approaching the halfway mark in May this year. We have 552 individuals registered with the rail cluster, 361 organisations, and of these organisations, 195 are SMEs from a huge variety of backgrounds and sectors such as marine, oil and gas, renewables, aerospace and automotive. We're still growing, which is great. We had 10 new companies registered in April and 8 of them are SMEs. So there's definite continued interest in what we're doing in this project and the rail sector and the opportunities it offers. The breadth of expertise and skills we have locally in our doorstep in Scotland with the SME community, it has been a bit of an eye-opener for me. The rail industry presents multi-sector diversification potential for SMEs, especially where there might be synergies or opportunities to adapt their services and products to make them work in the rail sector, such as we've got fabricators, we've got precision engineers, instrumentation and control businesses, metal manufacturing, battery suppliers, leather producers, 3D printers, air conditioning manufacturers, and a whole lot more. So a huge range of SMEs in our project. So back to today, I'm really pleased to welcome our fantastic panel of speakers. We've got Bill Reeve, Rail Director from Transport Scotland. Bill will start us off with some context setting around the Rail Services Decarbonisation Action Plan issued last July. Bill will be followed by Jerry Agnew, who's the Director of the Hydrogen Accelerator from the University of St Andrews. Jerry will give us an overview of the Hydrogen Accelerator and the wider application of hydrogen across Scotland. Following on from Jerry's session, Richard Kemp-Harper, Strategy Director from Alkala, will talk about Scotland's first hydrogen train project in which work is underway to convert a Class 314 car passenger train ready for demonstration at COP26 in November this year in Glasgow. Following that session, we'll hold a panel interview style session where your questions will be asked to the panel. So please use the chat facility on Teams to post your questions. Then we'll have a quick 10-minute break to allow you to grab a coffee, and we'll return to hear from Jim Irvin, Head of Production Operations and Supply Chain from Alkala Energy, who will speak about hydrogen traction and opportunities for Scottish suppliers. A warm welcome also to Colin Mcelrith, Chief Operations Officer at Michelin Scotland Innovation Park, who'll conclude our event, and he'll give an overview of how the Locate initiative will deliver a new drivetrain test facility for zero-emission heavy-duty and niche vehicles in Scotland. We hope...
We just need to watch out. Sorry, Sean, I have to butt in. Paul here. Bill Reeve is having to reboot his laptop, so he might be slightly late connecting.
Okay.
So we might need to adjust times, but we'll check in a second when you're ready to see if he's still on.
Okay, no problem. We hope you enjoy this event, and just before I hand over to Bill, maybe not, we could maybe go to Jerry if Bill hasn't managed to get. We could go to Jerry first if Bill hasn't managed to sort his laptop. I'll quickly run through some housekeeping for everybody just to keep us on track, as we've got quite a full agenda for the time. I think I said at the beginning, please turn off your video and mute your sound so we don't distract the speakers or the attendees too. Please use the chat facility to post any of your questions. We'll have the panel session in the middle, and we'll have Q&A at the end after Jim and Colin. And finally, just a quick reminder that today's event is being recorded and will be shared after today for those who can't attend, or if you want to watch back. And now that's really the end of my little bit, and I'm not sure if Bill's back on or not.
Shona, it doesn't look like Bill's on yet.
Okay. Jerry, would it be all right if you maybe did your presentation?
Yeah, I can do that.
Great.
Let's do that, and I'll just make sure I change 1 or 2 points a little. Yeah, it's not a problem. Let's do that. I will share my presentation now. Here we go.
Thank you.
Share. I think pick the right slide, and then make that full screen. Hopefully that's okay. You can see that okay?
Perfect. Yep.
Great.
Thank you very much.
Okay. Well, thank you very much, Shona and team, for inviting myself and the Hydrogen Accelerator here today. Very interesting times with a lot of activity going on in this space. And with that, I'll move on to the next slide. We start with a brief summary of what the Hydrogen Accelerator is, focusing on its mission and objectives. And then we'll get into some more specifics about what's going on in the rail cluster. So Hydrogen Accelerator has been running since June last year. Our mission is to really make hydrogen happen for Scotland, with a focus on transport. The main 4 aspects of that are across the top there. I won't read them out directly. They're there for you to look at. Key roles are around doing things like technology assessment, matchmaking, helping with optimizing things and standardizing things. And a very important part of it is outreach and communication. And typical activities span from helping people identify funding. We don't directly provide funding, so if you're thinking of knocking at our door for a few million quid to do something, we can help you go somewhere else to find that money. We can help put consortia together. A key part of it is also about identifying Scottish supply chain, helping them develop. And a very important mechanism for doing this is by sharing learning and experience that's being developed from other hydrogen projects. Some of the team have got tremendous experience, we'll talk about in a moment. And then developing risk management strategies and essentially promoting the health and safety that is important whenever you work with a fuel, as much with hydrogen as any other fuel. The key stakeholders in the Hydrogen Accelerator, well, firstly, it's an activity that involves collaboration between University of St Andrews and University of Strathclyde. When COVID restrictions would finally dissolve away, will be centred at the Eden campus, with obviously close involvement with the PNDC, Power Network Demonstration Centre at Strathclyde. And we'll talk a little bit more about that at the end, about the ecosystem around testing and development for this space. And then obviously we touch upon academic experts. Industry is a very big part of what we do, probably should be a bigger box in this. It's just the way it's got drawn out. Research institutions in the public sector, and the whole thing wouldn't be possible without Transport Scotland, front and centre, who enabled the Hydrogen Accelerator to happen. Briefly show you the team. You may even recognise some of these individuals from the photographs, which aren't necessarily 100% representative. John Irvine's been working in the hydrogen and fuel cell and electrolyser space for many years at St Andrews. And in fact, the reason why I know John is because of previous work I did at Rolls-Royce brought me there, as it did indeed bring me to Strathclyde as well to work with our Deputy Chair, Graham Burt. And then we've got our operations manager, Sneh Jain, who you will know from other activities, including the Low Carbon Challenge Fund and the Energy Technology Partnership. Many of you may also know Fiona Landy, who's been very active in the hydrogen space and has been at the heart of many of the best projects around hydrogen in Scotland. And then we've got two more recent team members have joined us, Martin Verbracken and Kimberly Tweedy, both of whom themselves have got experience in the space from both academia and industry. Very briefly, some of our achievements so far, just so you know what we've been doing. So we've been involved in the procurement of and development of the zero emission train. We'll talk a bit more about that in a moment. The Dundee bus project, where we've been doing key bits of work that needs to be filled in, techno-economic analysis, providing a tech spec for the hydrogen refueling station, and so on. Very much involved with Glasgow Transport Decarbonisation Strategy and Eric Stewart's excellent approach to making hydrogen affordable by sweating the assets that he brings in. So very interesting story there for another day. And then we're involved with the Highlands side of hydrogen development, Locate, which is something we'll mention at the end. And we're at an early stage of getting involved with the Western Isles and supporting the local authority there and key stakeholders around hydrogen, with touching on one or two other bits and pieces. So, and I would say there's also a lot of involvement with some of the big companies in that space and some of the SMEs who are really critical to making it happen. With that, I'd like to move on to looking at rail in Scotland and the value of hydrogen in the context of rail. And this is where it would be ideal to have had Bill's talk first, but you just have to swap around in your mind. Essentially, we hang off of the strategy work that Bill's involved in. So essentially, you would have seen from Bill the vision of how decarbonisation will be carried out for Scotland for rail, and it makes great sense to wire a lot of stuff up, but you can't wire up everything. There are some bridges and tunnels that are less suited to electrification. Some routes where getting the power there is very geographically challenging, and what you can't wire up needs to be self-powered, especially if it's to fit some sensible operational requirements. So then you need to look for the right energy storage to enable that self-powering, and we'll just have a quick look at the possible options there and why hydrogen has a right role to play in that. The right energy storage can complement and de-risk electrification. There's a long transition to be gone through, a few 100 miles worth of route change each year into electrification. There has to be solutions in the meantime that enable us to save carbon sooner as part of that transition. And there are some routes shown on green on the left of that map there that fundamentally in the end don't suit electrification and are likely to be provided entirely by hydrogen, and then hydrogen playing a transitional role in helping implement the rest of that electrification strategy. So what's the right energy storage for this problem? And essentially, when you look at, if you want to put numbers to this, a very good way to look at energy storage is in a Ragone plot. That's got energy up the y-axis, and across the bottom you've got the power, that's watts per kilo. So watts per kilo across the bottom, watt hours per kilo going up the side. And if you look at the different requirements, you find that essentially you can address many of the lower emission requirements with things like batteries. And when you look at mission time, it turns out that when you divide it all out, you find that there are lines of constant mission that run diagonally across these plots. So a 6-minute mission is over here, a 1-hour mission is here, a 10-hour mission is this line here. And you can see that essentially there isn't enough stored energy in a battery solution to get beyond the electric cars into the longer mission heavy duty vehicles and train journeys. So you could do a train journey. You could take this train point here and you could say, I want to do a train for a very short mission. I could drop it vertically down. In practice, it would move a little to the right. And what you'd find is essentially, if I had a one hour mission for a train, yes, I could think about doing it with batteries. So there are opportunities where batteries make sense for the train kind of powering solution. But most places, a 1-hour mission doesn't make sense. From an operational perspective, you want to be able to operate the train for the whole day and do the energy top up at the end of the day, be that refueling with diesel historically, filling it back up with hydrogen, or charging if it's an electric system. So what happens essentially is, for these more demanding applications, you need a better energy store. The graph is logarithmic. So just caution that essentially, although some of these small step-ups look as if they're within grasp for battery development, these logarithmic plots mean that current state-of-the-art battery improvement wouldn't get to beyond the blue writing in 20 years. So essentially, batteries have a fantastic role to play for the short mission. They enable the hybrids for fuel cells and other vehicles to do decarbonisation. But you need this longer energy storage, and essentially for the very long missions like flight, transatlantic flight, you need things like ammonia or synthetic fuels. But there's a lot of applications in that middle space where hydrogen makes sense, and that's where the train is absolutely a good fit for this. Just to emphasize that there. Okay, with that, we can move on. We've noted that if you get the right energy storage solution, it can complement electrification and enable more rapid decarbonisation. So the other thing then to talk about is how to bring about that decarbonisation and how to bring hydrogen to scale. From that point of view, it all has to be part of a just transition. A key part of hydrogen is the economic development that can go with it. We need to align major changes around decarbonisation with things that will bring other benefits in the economy. It makes sense to develop high value jobs around the decarbonisation strategy in Scotland and anywhere else for that matter. And so a key part of the success of hydrogen is essentially fitting it into the growth in jobs that are needed, exploiting existing capability, the very strong proven oil and gas capability in Scotland and its fantastic reputation as something to build on with hydrogen. It's an adjacency that naturally fits with that. Scotland's got a long history of rail innovation. I won't tell a bunch of rail enthusiasts about that. I would get that wrong, but I know many things I can cite. There's also the opportunity to align with modal shift and sector coupling. Essentially, people moving about the place differently in a new decarbonised transport world. Rail can fit into that very well. Hydrogen can enable that. And finally, there's the opportunity to do things like decarbonising freight as well. And a key part of this is cooperating across sectors. So hydrogen supply being coordinated between activities such as buses, maybe distilleries that are nearby, other infrastructure that's using hydrogen. Cross-sector cooperation can de-risk the investments necessary to make hydrogen work. I move on then to the actual importance of the zero emission train project itself. So it de-risks this pathway. It's about creating the first jobs within this sector. It's about alerting the supply chain and initiating development of capability. So yes, we're building a train, but there's more to it. It's the big picture that matters. It's also a very important opportunity to bring key stakeholders into the thinking early, start the dialogue. I'll explain what phase 3 is in a moment. The phases on the next slide. It begins the outreach and social acceptance by the general public. The general public, some of them are now quite familiar with hydrogen. Some have just heard things off the telly and bits on Bond films. We have to bring them back into reality about the fact that hydrogen is a very safe solution for decarbonisation. So the zero emission train project in more detail, phase 1 has already been completed. That was explored the challenges around converting roll stock and indicated the feasibility. That was completed back in April of 2020. Phase 2, which we're right in the thick of now, is a limited demonstration of converted Class 314 for COP26. And the key objectives, and they are big picture objectives, it's not about just getting the train up and down the track. It's about proving that Scotland can have the capability, especially to convert existing rail stock and assets, that we can work with regulatory bodies and develop the necessary standards, that we can inform rail policy for passengers, especially around power multiple units. We can demonstrate to the Team Scotland community around rail the operation of hydrogen in a passenger context, and start the process of providing the supply chain with opportunity to develop their skills, provide educational institutes the opportunity to develop their skills, and the two are linked there, and we mentioned that again at the very end of the presentation. There is also going to be a phase 3. We're hoping that will be clarified more in the next coming months, but essentially that's about a separately funded future activity to deliver a fully capable pilot train on the network. Okay, I won't get too much into the detail here. I'm going to skim over the progress. That's going to be covered in detail by Richard, and the supply chain aspects by Jim, who we're talking a little bit later this morning. Some of you will recognise the pictures of the train being transported past the Kelpies only a few months back. It's already intensively being worked by the crews there at the Bowness and Kinneil Heritage Railway, who very kindly made a facility available to work on this. And you've got there a team working from Bowness and Kinneil. You've got people from the rail industry they brought in from wider there. You've got Alkala. You've got the Alkala collaboration. So that's people from Arup and Abbott Risk Consulting. Aegis are the independent safety check from the outside. So you won't see them down there looking at the bits and pieces, but they're in the project as well. And it's very actively being worked. The train's being stripped, supply chain are being engaged, and a route to market study is at an advanced stage. Lots of good work on the design and ordering of long lead time components, but I'll leave that to Richard. I'll finish up with my last slide, essentially about the ecosystem for rail and decarbonisation with hydrogen. There is now a growing ecosystem to support getting into this space and to de-risk people wanting to move across into this space. In the centre of it all, you've got the DER project, essentially for the Scotland's driving the electric revolution, and there are key facilities hanging off of that and resources that can be accessed depending upon the scale and the phase of the work that's being done. There's different people. So later you'll hear from Colin about the Locate validation stage testing facility that's being put in at MSIP, and it was announced recently. And a very important part of it, PNDC, who play a critical role in the development of capability. You've got the Hydrogen Accelerator we've already mentioned. And then you've got other important related activities. You've got NMIS, the National Manufacturing Institute of Scotland, within whom is the Advanced Forming Research Centre, world-class forming knowledge for making shaping, especially metals and other materials, and the James Watt Nanofabrication Centre for the latest small-scale technology. These are complementary. A lot of thought's gone into making sure how they fit together. PNDC deals with the more flexible R&D up to high TRL, but where you need direct university involvement and clever things such as scale tests of things. Locate is aimed at an operational focus. It's aimed at full mission testing, the right-hand side of the V diagram further up than where PNDC is. So for those who are familiar with the V diagram of engineering development, it has a different location there on the right-hand side. And then the last thing I'd say is that this ecosystem is there to allow supply chain to explore adjacencies and move into hydrogen and decarbonisation at least risk. And that will include also battery vehicles and hybrids, because hybrid hydrogen solutions only work with batteries in them to balance the energy profile and use. So with that, I'd like to hand on. I was planning to hand on to Richard, but I think Shona, I should probably hand to Bill. Should I? Is that then?
Yes, I think Bill's back. If you're able, Bill, it would be great to have your presentation next. Thank you very much, Jerry. That was great.
Yeah.
Thank you, Jerry. Thank you, Shona. I'm just checking you can hear me and possibly even see me now.
Yes, both.
Hurrah. Shona, I think given the digital dilemma I've had for the last 25 minutes, which is thanks to Microsoft, a bit of my life I shall never get back. I wonder if I might ask you to drive the slides, just in case the fragility of my current arrangement is a step too far. Is that doable?
Yes, of course. I'll just share them just now.
And whilst you're getting the slides up, can I just say what a pleasure it is to be able to address this gathering. I'm really sorry to have missed the first part of Jerry's presentation, except I can confide that I had the opportunity to see a presentation from Jerry only the last week or so, and we have talked about this before, so I know you will you just have had an interesting treat. I think it falls for me to try and give you an explanation of the context in which the hydrogen train and indeed other decarbonisation projects on the rail system exist, and tell you a little bit about the approach of the Scottish Government to this, why we think this is vitally important work, and why we are so keen to attract businesses to invest in and develop their business in Scotland in support of our low carbon economy. Now, what I don't know is what you can see at the moment and whether the slides are coming or not.
So the slides are up on the screen, Bill, and it's the first slide, your cover slide that's up just now. Would you like me to move it forward?
That would be sensible, and I will pull up the slide, my slide at this end. Give me one moment. I really am having a mildly frustrating, to say the least, IT day today.
Don't worry.
One moment, callers. So look, I suppose it's been a bit of a year, hasn't it, for everyone in whatever sector of the economy you found yourselves in, or indeed whichever country you found yourself in. But nonetheless, in the midst of all of these challenges, we have seen it as hugely important not just to deal with the challenges of the moment, but to press on with the vital task of decarbonisation. But I think the slide you have at the minute, for those who are not familiar with the network of Scotland, is just to illustrate the scale of our network, which is about 11% of the GB-wide railway and a substantial network in its own right by comparison with a number of other nations. It is a network that we are continuing to invest in because of the vital role it plays in connecting communities and in the sustainable transport of freight. Prior to COVID, it was a thriving and successful and growing network. No surprises that in the last year or so, we've had a drop at its lowest point down to about 10% of pre-COVID passenger patronage, back up nearer 30% now, as there's a gradual unlocking. But the freight sector has continued to deliver vital services to the nation, and indeed the passenger railway has moved folk involved in delivery of essential services. So, and we even managed to open a new station in the middle of all of that. So, next slide, please.
That's it.
Which should show a statement of the Scottish Government's purpose. We spend, in an ordinary year, the turnover of the Scottish railway industry is in the order of £1.5 billion or a little bit more, of which a little more than £1 billion is funded by the Scottish Government to sustain and operate the current network and to invest in the future of that network. Why do we spend all of that money? Well, it's in support of this objective. It is to focus government and public services on creating a more successful country, with opportunities for all of Scotland to flourish through increasing sustainable economic growth. And rail systems have a hugely important part to play in delivering that sustainable economic growth for the nation and its communities. Next slide, please.
That's it.
Which should have a picture of our current First Minister. And this is really just a point I was making earlier, that even in the midst of our challenges dealing with the COVID emergency, we have had to look forward and lift our sights to the importance of building back a fairer and stronger country. And we have to keep our focus on using the opportunities actually to deliver the fairer, greener and more prosperous Scotland. And on to the next slide, please.
That's it.
Which should now show our a summary of our national transport strategy. This is what all of that money we spend on the railway, indeed all of the money we spend on any bit of our transport system, should be doing. We are using our investment in transport to reduce inequalities, to take climate action, to help deliver inclusive economic growth and to improve our health and well-being. And we have a very clear hierarchy of the sort of transport we are looking to encourage. Indeed, one of the upsides of the last year has been a real growth in walking and wheeling and cycling, which are the most sustainable forms of transport. After that, we want people to use public transport, taxis and shared transport, and worst of all, in terms of moving people, the private car. Much the same might be said, by the way, of the movement of goods as well. And if we invest in the right transport system, and if we invest in encouraging suppliers to locate in Scotland to deliver that transport system, then we do produce reductions in emissions, cleaner air. We do encourage people to walk to and from public transport, which improves their health. We do help deliver that inclusive economic growth. We certainly address the urgency of climate change. And with that sustainable connectivity in a public transport network, we help reduce inequalities as well. On to the next slide, please. So talking about the climate change issue, where does rail fit in the dilemma? Well, there's some bad news and some good news on this slide. The bad news is that transport is on the naughty step when it comes to climate change and emissions. So as we have decarbonised various bits of our economy, notably, for example, power generation, transport has remained a stubbornly high contributor of greenhouse gases. And in Scotland, our analysis tells us 37% of Scotland's greenhouse gas emissions are accounted for by transport. And that is not all right, and that cannot remain. But if you look at that chart, you'll see the obvious guilty parties: the private car delivering 40% of those emissions. Interestingly, vans and heavy goods vehicles, another 25%. The horror, which is aviation in emission terms, 15%. Shipping, interestingly, surprisingly polluting at 15%. But rail is only 1.2% of that 37%. So why on earth would that be something that would be a priority for decarbonising? Well, the answer is really quite straightforward. We need to move people out of their private cars and goods out of those lorries and into the environmentally sustainable rail network. And then we need to remove the remaining emissions that rail network accounts for, because that's what takes us to the zero emission transport solution. We cannot hit our climate change targets for Scotland without modal shift onto public transport and indeed of goods onto more sustainable transport modes. So this is a mission critical investment, because those are not just targets announced to the world, they are actually legal obligations, and that really does focus the mind of government and indeed the allocation of resources. Next slide, please. Which should now show a swift reprise of what's happening across transport. We are working, of course, to phase out petrol and diesel cars. We are actually looking at how to decarbonize aviation, including the practical proposition of electric aircraft for short hop flights for some of our island connectivity. There is a commitment to the deployment of zero emission buses across Scotland, and in 2030, and we have announced a commitment to decarbonize our rail services by 2035, which leads us neatly on to the next slide. Now there is a picture of the current Cabinet Secretary back in July of last year, holding up a map we'll come to in a moment, but announcing the launch of the Decarbonisation Action Plan for Rail. So think yourself back to July. We were a few months into the pandemic. Of course, there was a necessary focus on dealing with that, but that recognition of the essential focus on decarbonisation meant that we still went ahead and published that Decarbonisation Action Plan, and we have been working hard to deliver what is in that plan ever since. Next slide, please. So how do we decarbonise rail? Well, we have some choices, and I think you should see a picture there of an illustration of one option for deploying fuel cells and hydrogen on rolling stock fitting within the loading gauge of the British Railway network. I have to say our principal aim is to electrify the network. For the busiest bits of the network, we are persuaded that the efficiency, the inherent efficiency of simple electric railway is attractive. It's about an 80 to 90% total system efficiency. It delivers bluntly unlimited power to the train, the limits being how you can deploy it between the wheel and the rail. It allows us to operate lighter trains, faster trains, lower cost trains, more reliable trains. In fact, when you put it like that, the only question is, why wouldn't you? Well, we will be electrifying an awful lot of our network, but it is going to take us a little while to get there, which does mean that we need to make use of alternative technologies in two ways. Firstly, to facilitate our transition from the current network, which still has a proportion of diesel trains operating on it. And secondly, because classic electrification brings with it a very high capital cost in the fixed infrastructure for the power distribution systems. And that is justified where we have high traffic density. But on some of our more lightly used routes, particularly in some of our rural areas, the operating cost benefits will not justify that capital investment. So battery technology and fuel cell technology is a vital part of the appropriate mix of decarbonising technologies we need for our rail network, which leads us on, I think, to the next slide. And this is a slightly broader point. When investing in a railway system, we have to look at it as a system. We have to consider the services we want to run through the timetable. We need to consider the capability of the rolling stock and the infrastructure that most efficiently facilitates that service timetable and that rolling stock for passenger and freight services. But I think if you look at how we align our investments to our priorities, we do have a real focus on value for money, importantly in operating costs and the revenue that's attracted to those rail services linked to the initial capital investment decision. We are prepared to invest in developing our rail system where it represents good value for money. Really importantly, in Scotland, we have maintained consistently a much steadier work bank of railway investments than you will have seen further south of the border. we have maintained a rolling programme of electrification, and we have tried to maintain, and have certainly been more successful than elsewhere, a steady programme of rolling stock investment, both in re-engineering and in the acquisition of new, because we don't think peaks and troughs are good either for the practicalities of deployment of that technology, nor indeed, and this is the really important point, in encouraging the establishment of supply chains who can depend upon that steady work bank, and therefore are prepared to invest in the staff, the training, and indeed the equipment necessary to meet that rolling programme of investment. So on to the next slide, please. A quick reprise of what we have already. Our current network, we are making good progress. That we've maintained that rolling programme of investment in decarbonising our railway. No surprises, it's focused in the central belt and on the links to England, where our busiest traffic density is. We now have all of the routes between Edinburgh and Glasgow electrified, which means that 76% of all our Scottish Rail passenger journeys and 45% of our freight journeys are currently undertaken with fully electric services. But you will already have done the maths and realise that that means 24% of our rail passenger journeys and 55% of our freight is still being hauled by diesel, and we need to change that urgently. Next slide, please. Talked about that rolling programme of investment, the focus on technology being applied to rolling stock today. Just to give you a sense of that, the scale of what we have to achieve, something like 70% of our fleet will become life expired over the next 15 years. So we've got the diesel trains that operate things like our West Highland services and Stranraer services, and indeed to East Kilbride. We've got some of our older electric units that have served us well, but are coming up to the end of their time. We have got, by 2030, we will need to be replacing the trains that are running on things like the Far North Line and in Fife, and our re-engineered high-speed trains, which are being deployed across Scotland as we speak. And then by 2035, we need to replace the last of our passenger diesel fleets. And there will, of course, need to be, in the freight sector, equivalent investments in rolling stock assets for freight trains. Our next slide would take us to, I'm having quick check, we should now have a map saying decarbonisation 2020 to 2035.
Yes.
Hurrah, the system works. Thank you, Shana. On that picture, you will see a map of the aforementioned rail network of Scotland. The red lines are already in the good category of being fully electrified, but the map on the right, which shows the 2035 plan, is in many ways the more interesting one, because it shows a commitment to decarbonise the trunk routes to Inverness and to Aberdeen. It shows that we'll want to go on and do similar work between Aberdeen and Inverness. But even given the scale of ambition that we have in Scotland, I think I am struggling to believe that we will ever string the wires up to Wick and Thurso and Kyle of Loch Elsh, Stranraer, or indeed Oban, Fort William and Mallaig. And please remember what I said earlier about the need for us to accelerate our rail decarbonisation through the use of alternative technologies to the straight electric train as part of our transition period. So wherever the wires get to at any point in that 15-year period, there will always tantalisingly be a bit of railway beyond where hybrid technology will have an important role to play in extending our decarbonisation benefits. Next slide, please. Which should bring us back to the importance of innovation, jobs and the economy, and really the focus of this conference today. With that scale of investment and commitment to a sustainable transport system, with rail's essential part within that, We want to stimulate innovation in the manufacturing industry and the wider supply chains. And we really want to create skilled, sustainable employment in Scotland, both in that investment in the infrastructure and of the provision of the equipment to run on that infrastructure, and then indeed to maintain and service and develop it thereafter. We are really keen to see the high quality work that the rail sector can generate located in Scotland. We have the characteristic Scottish focus on the value of money, and we like to have our money work twice for us. When we are spending money on providing transport services, we'd like that money first to underwrite the operation of those services, and secondly, to create additional jobs through the provision of the equipment for those services. And we do that in collaboration with our partners in Scottish enterprise, and increasingly in collaboration with partners in the education sector, and indeed with some of the companies that I'm very pleased to see represented here today. Next slide, please. Now, I suspect, courtesy of the joys of IT, that you already know more about this project than this trailing slide was meant to say. But this is why we are investing in. You see a picture there of one of our older EMUs, already withdrawn from frontline service, but being transported to Bowness, where even as we speak, it is being worked on. And it will be a matter of lasting regret to me that we didn't clean the graffiti off the train before we moved it. But I still think that's a great picture. So for the avoidance of doubt, any trains in service do not have graffiti on. That one had just stood too long in a siding before that movement. But this is what we're trying to achieve. We want to prove the Scottish capability of installing hydrogen fuel cells and their integration with batteries and control equipment. We want to use this project to drive the development of the necessary standards in conjunction with the various standard setting and safety bodies. We want to see what lessons we can learn to help us refine that 2035 decarbonisation rollout and that optimum mix of technologies within it. We really want to demonstrate, because there's no substitute for demonstrating the practical operation of a fuel cell passenger rolling stock. And this brings us back to the purpose of today. We want to develop that supply chain and its skills and knowledge within Scotland so that it can supply both Scotland and indeed the rest of the world. And we believe that we will be successful in doing that, working in partnership with educational institutions for research and practical application of that world-leading technology within the rail industry in Scotland. And I think that should take us to the final slide. So, with apologies again for the late arrival of this particular train presentation, I hope nonetheless you have found that to be of interest. Thank you.
Thanks very much, Bill. That was great. I'll stop presenting and then hand over to Richard. Thank you.
Hi everyone. So Sharon, I'll just check that my slide is up there for everyone.
Yes.
So my name's Richard Kemp-Harper, very well introduced by Jerry and by Bill to talk a bit more about the Scottish Hydrogen Train project. That self-same image there that we all love, Bill. I promise you, if the graffiti isn't off the train already, it will be very shortly. The team are working on smartening up the vehicle to it's probably as good as it's looked for some considerable time. A quick introduction for Alkala Energy. We are system integrators working in fuel cells and hydrogen technology for 11 years or more. We've built a really strong capability in joining the various technologies together, from tanks through fuel cells, batteries and traction systems, and we're mainly focusing on the heavy end of transport that Bill highlighted in his decarbonisation wheel, particularly the trucks, buses, and now through this project looking at transferring that technology from automotive into rail. And one of the things we're doing is a lot of work in Scotland, looking at projects in a number of cities for very different types of vehicles, and partly through that work, we are investing in a facility at Michelin Scotland Innovation Park, and you will hear from Colin at Msip. There are a landlord there later in this session, and we will be having an assembly and vehicle integration facility at that plant, and looking forward to being part of the low carbon transport ecosystem that's being built there, alongside, and you'll hear from Colin, the Locate testing centre, which is a crucial part of what we need as a developer to be able to put our technology up to the level you need to have robust vehicles running in service with public sector fleets in rail and private sector fleets as well. Develop the technology beyond the demonstrators and really up to OEM quality of product with our knowledge that we've got to date, bringing that up to the level that customers expect of reliability, robustness and cost. So back to the project, and this is the third time I think you've seen this set of objectives. That's on the left of that picture there, that's Ben, our CEO, with Michael Matheson, I'm sure somebody Bill knows very well, Cabinet Secretary for Transport, kicking off the train project when it was announced 6 months or so ago. But here are the objectives of the project, and I guess the thing to emphasise here, without going through all of them again, is that the first point about proving Scotland's capability to modify rolling stock. We see ourselves as Alkala Energy as the sharp end of the wedge to drive that home, investing in Msip and our facility there, but then pulling through the supply chain for the various components and systems and assemblies that we need to make the train a reality. And again, that's the purpose. Point 5 of what we're doing today is to highlight our approach, highlight our technology, and look at the opportunities that there is for Scottish supply chain to work with us to do exactly what Bill was talking about, to address the decarbonisation problem for Scotland's railway with solutions that can be built in Scotland. Jim's going to say, Jim Avern, my colleague, is going to say a bit more about the technology and what specifics of the opportunities a bit later. I'm going to talk a bit more about the train project and the technology at a higher level, and how we see, from a perspective of a hydrogen technology developer, how we see the rollout and the market development and the route, if you like, to market that is part of the project, as Jerry highlighted. So let's start with an insight into the capabilities of these vehicles. We've got deep experience in Alkala of modelling powertrains and understanding how the traction demands of a vehicle translates into the system requirements and therefore the energy needs and the hydrogen use on a number of vehicles. We've done this in buses and validated it in buses and trucks. And this is an application of that same process to understanding the energy demands on the rail application. So this is modelling the route, the far north line. You probably just see there the climb over Inverness to the Carl House and the bottom chart and back, and then Ardgate to Inverness, different parts of that route, and the speed profile of that network. And on the right, then we've got our powertrain modelling output and what that looks like in terms of fuel cell power, battery state of charge, and hydrogen usage. So that's given us an understanding and a real depth of the energy demands and therefore the capabilities of what a hydrogen train needs to do to fill the gaps in some of the routes that Jerry and Bill have highlighted on the chart of the map of Scotland. So we've carried this out for two different train types. Again, the one Class 158 and 170 are two familiar trains you will know that were referenced in Bill's presentation as well. And just as a high level number for that route, these are the sorts of energy demands and hydrogen usage that we're looking at. So the 2-car 158 uses about 25 kilograms of hydrogen per 100 kilometre on that Far North Line route, and then the Class 170 uses 28 kilograms per 100 kilometre, and that's a 3-car set. So just to give you a sense of what that looks like in reality, 25 kilograms of hydrogen is about 3 cylinders, 2 metre long and 50 centimetre in diameter. So if you imagine that package under the train, that's about 1.5 meters of space under a train. It gives you that distance. There you can see, how we're packaging, in outline at least, the conversion of the 314. Hydrogen storage there under the train under the left-hand doors, the fuel cell and battery and other equipment under the right-hand doors. It's an indicative layout of what this looks like. Each set on rafts, supported and mounted onto the train. Just to give you a contrast, therefore, with how hydrogen sits and Jerry's point about why hydrogen and why not batteries. 25 kilograms of hydrogen in tanks weighs around 500 kilograms. That amount of energy in batteries, to do that 100 kilometers of distance, is about 3.5 tons. You've got to add mass of the fuel cell, but essentially there's a significant difference there in the mass characteristics, and that just gives you some harder numbers, if you like, for what that chart that Jerry showed about why batteries can do useful and have a useful role in a railway, and we'll come on to that a bit further. But there is a limitation, particularly in terms of that mass and packaging the batteries into a train. The second point there, if you look at the hydrogen train, then an optimized design on the 2-car set, we can probably fit around 200 kilograms of hydrogen, and that's sufficient for, I may be getting the words wrong, but for that Inverness Kyla Blockhouse route, that's comfortably do the full day on that capability. But an important point that was a surprise to me, the energy jump from the 2-car set to the 3-car set wasn't that great. Energy use does not increase linearly with the length of the train. That's because the major drivers of the energy use are the rolling resistance and the air resistance. And trains, as we know, are both very efficient from that rolling resistance point of view and aerodynamic because of the length of the train. So energy use doesn't go up linearly with the length of the train, but hydrogen storage capacity does. The more of that space we have available under a train to put the hydrogen tanks, the more range you can go. So therefore, interestingly, longer trains go further with hydrogen. And a back of the envelope calculation suggests that if you had a 6-car set, then you've got an opportunity potentially, and this is early days in these calculations, to do 1,500 kilometers or more. And that sort of level, we're getting close to full diesel equivalents for the sort of range and capabilities of a train. There's a lot more work to do on this, but I think that's an indication of the range of capability that hydrogen can bring, and starting to see the sort of shape of what the architecture of these sorts of rolling stock will look like. So just then to compare battery electric, I want to emphasize that we see these technologies as the same in road as it is in rail. The hydrogen and battery trains and the technologies are complementary, and there's a role for both on the network. Battery electric trains are a nice, simple powertrain. They work really well in a bi-mode capability, so overhead wires and some battery capacity on the train. And particularly, they're really good for allowing that short, no wires running. Jerry highlighted this, through tunnels, at the end of lines where you might not electrify, and through that, helping to reduce the cost of electrification. But the constraint is they've got this limited range capability because of the mass of the batteries, and that, as Jerry points out, however long in time you go, there are limits to chemistry and how far that's going to develop. Hydrogen fuel cell electric trains, though, they're similar to electric. You can have a bi-mode capability, and I see that as being a really interesting area to explore. But otherwise, as self-powered trains, they can play a similar role to diesel. As I say, we can almost get this diesel equivalent range with the right architecture and right sort of train. And for those lines that require self-powered, hydrogen fuel cell electric looks like a really good solution. I think the point I would emphasize is that hydrogen trains provide us with options for how we roll out the electrification across the network. The downsides are there is a more complex powertrain and a more complex infrastructure, but the benefits are actually quite good routes to decarbonisation at relatively low cost compared to other things, particularly for those routes that are at the extremities of the network. Looking at how you do this in terms of what sort of rolling stock you look for, there is always the option for the new build hydrogen trains. The ones that are actually furthest down the line, if I can use that phrase, in this technology is the Alstom train, which has been at service in Germany for 4 or 5 years now. Mature technology, been in service and being rolled out in several places in Europe now. And new build trains, you would want to have a large fleet to do a full transition. You're looking at a long-term investment and commitment and working with mainstream OEMs. Be interesting to see whether there's an opportunity for that to happen in Scotland, and look forward to potentially for doing things in Scotland. But it actually doesn't perhaps sit well with the sort of things that Bill was talking about in terms of how you might use this train and this type of technology to support the decarbonisation of Scotland's railway. On the other hand, looking at repowering of existing DMU or EMU rolling stock, there are some nice things within this that may make it look like a better way to go. So life extension for fleets that are going to be retired otherwise. We need to remove particularly DMUs from the network. Can we extend the life of those by repowering those to be zero emission? Potentially it's a lower cost and lower commitment than a new build train. You're making a use of the existing asset, and actually the refurbishment is not that great a cost. Potentially it enables an earlier transition for small fleets. So instead of looking at that long-term commitment to an expensive new train, the extremities of the Scotland's network and elsewhere on the GB railway, potentially this enables a good route to doing those sorts of deployments. And maybe we can deploy early and cascade to other routes and use this technology as a way to decarbonise early, but as an interim solution to enable the full electrification in the long term for the core of the network. And I think crucially for the supply chain point of view, this route provides more opportunities through organisations like Alkala Energy. Other integrators may be available. And through our investment in Scotland, again, we would like to be seeing ourselves as a route to supporting that supply chain development in Scotland. And just to give you a sense of the numbers, there are 75 trains in Scotland of those sort of 158 or class 170 type that could be converted. You've seen this chart before. Very quickly, I've said some of this already. I see hydrogen trains as providing a route to virtual electrification, renewable energy into hydrogen at one end of the line, then put that into the trains, it's converted back to electricity on the trains by the fuel cell, and therefore you've got a virtual electrification of the line at probably something which is like an order of magnitude cheaper than doing the full electrification. As Bill says, there is the efficiency trade-off you've got with that. But that sort of capex cost reduction really works for these routes that will never be or unlikely to be fully electrified, particularly where you've got rural locations with plenty of renewables. And perhaps that low cost and reuse of existing rolling stock may help us provide an interim solution to support early electrification, and early decarbonisation. Maybe with bimode rolling stock, as the line is electrified, the hydrogen side of the train can provide the train with the capability to go beyond the end of the network. Looking at wider opportunities in the rest of the GB railway, there are current plans of Network Rail, similar network extremities, but my view is that there is an interim solution that could be a much bigger opportunity supporting early decarbonisation across the rest of the GB network, as potentially there is in Scotland. And I think my view, this might seem odd coming from someone promoting hydrogen technology, but I think I fully agree with Bill that we should be committing to a rolling electrification plan across the GB network, but also exploring the rollout of hydrogen trains and their use to support that programme. There was a quote recently from the Secretary of State for Transport that suggested that hydrogen trains were a technology beyond electrification. I think that's a mistake. The preference is always electrification, but how do we use hydrogen trains to support that process? Because decarbonisation is the objective. So very quickly then, just finishing off with how we think we get there and what it looks like. Jerry put phase numbers on this. The current project is phase 2 to demonstrate Scotland's capability. The next stage, phase 3, will be a long-term en route trial of a particular train, including the infrastructure, to understand the operations a bit more. That would be followed with a pilot passenger service and operations, and then flowing through into a first fleet, which potentially could be up on the Far North Line by as early as 2025, in my view. I think there's a good route map that shows that that's possible. In parallel, let's help inform Bill's world of the strategy and the policy discussions to align deployment with electrification and work with industry partners and supply chain to build the capability in Scotland to deliver it. Thank you very much.
Brilliant, thank you very much, Richard, Bill and Jerry. We're running a little bit behind, so I'm just going to ask a couple of questions that came through the chat facility. Casper Lucas asks, to what extent is retrofitting hydrogen capability to existing rolling stock directly applicable to Scottish rail decarbonisation, where hydrogen traction is proposed for rural fleets only according to published information? Who would like to take, is that a Bill question or?
I'm happy to start the answering at the very least, if that's helpful. The answer is it's eminently applicable. One of the things we perhaps don't give as much consideration to as we should is the amount of embedded carbon we already have in our transport systems, and the extent to which re-engineering of existing assets is the appropriate choice, as long as we can satisfy ourselves that the re-engineered product meets the requirements that we need. So there is, you will see in our current mix of fleets that we have a mix of new trains and re-engineered trains, and we often run our procurements in a manner that makes clear there's a level of neutrality in our approach to the evaluation in that respect as well. So put simply, we don't have a prejudice against the old, neither do we have a prejudice against the new. We will take a sensible, balanced decision with respect to that, and where it is possible to reuse and life extend an asset in an economically advantageous way, then of course we will. And there's quite a lot of research that demonstrates most passengers cannot tell the difference between a new train and a re-engineered train. It looks the same. Now, there may well be advantages in some of the new technology, but it does come at a cost. So there's a typical civil servant's answer. It all depends.
Thank you.
Certainly a very sensible approach for a number of circumstances.
Great. Does anyone on the panel have anything else to add?
Go ahead, Richard.
Yeah, well, I think I talked quite a bit about that in my slides, and I think the thing to add to what Bill said is that my point here would be, I think there's possibly a stronger opportunity for Scotland and the supply chain in that repowering, which perhaps add to that picture as well as the embedded carbon side.
And I would say that the other side as well is that it's an easier way to break down the problem in terms of capital investment, in terms of training and knowledge base, There's great advantage in trying to reuse existing rolling stock, but as Bill says, it won't always be possible. There'll be a point where that doesn't make sense, especially where you would think about putting a new hydrogen solution on a very old train. It would be, it'd be very challenging to make the capital case for that with the reduced life ahead of it. But where possible, it's great, and it's a great way to get the carbon footprint down.
Great. I'm just going to squeeze in one more question before we have a break. John Campbell asks, there are a number of hydrogen fuel cell rail projects involving industry and academia across the United Kingdom. Is there cooperation and shared learning across these projects?
Yeah, the answer to that, from our point of view, being involved clearly in one of those, is yes. And I think the cooperation and collaboration is particularly at the level of the developing standards around the introduction of hydrogen to the railway. The safety case for hydrogen still needs ongoing exploration. And ourselves, we created the structure of the team for hydrogen, the Scottish Hydrogen Train, including experts from Abbott Risk Consulting on the safety case side, and independent verification from Aegis. And we are working as a team with Network Rail, with Transport Scotland, with the key stakeholders, including RSSB, to make sure that we align our development with the ongoing standards. And I know that other teams on other projects are doing that, and the industry is pulling together in projects that key cross-sectoral, cross-project understanding of particularly the safety case and the implications for the railway of the introduction of hydrogen trains.
Yeah.
Great.
Should I add to that?
Yeah.
So I think it's a really important question. We obviously, collaboration is good. At the same time, we want to make sure we build robust business cases for those involved. I think a key role here is played by the Roscoes. They will be the driver of how this plays out in space. We welcome their engagement and some very interesting upcoming news in that space. We've seen some significant interest and activity from the Roscoes in the space, and they are essentially the people who will drive how much it's done collaboratively and so on. So, but it's great to see the whole, if you like, ecosystem of rail taking an interest in this and helping move it forward.
May just add a reflection, Shona. One of the things I have been very encouraged by is the number of parts of the wider rail industry looking to invest in hydrogen technology, who are attracted to bring their projects to Scotland and work with what we're doing in Scotland, because they are finding that here we have that alignment and collaboration between government, the university sector, and indeed industry. So don't listen to me, see how people vote with their projects and their money. But so far, I'm very encouraged by that feedback. It says that we are arranging this in the right manner. And I suppose it wouldn't be the first time that the rail sector in Scotland has proved to be a little more fleet of foot in the development of new technology and pursuit of cherished ambitions.
Great, thank you very much. I think now that we're at just after 11:15, we'll have a very short break. So instead of 10 minutes, I think just with the programme overrunning slightly, we'll be back at 20 past. The link is still the same link, so you can either just mute and put your video off or leave it running, it doesn't matter. But we'll be back at 11:20 and hear from Jim from Alkala Energy. Thank you so much to the presenters this morning, that was great.
Thank you.
Hello.
Hi everyone. I think that was a very fast 5 minutes to grab a coffee. I'd like to just continue on and introduce Jim from Alkala Energy. Over to you, Jim.
Thanks, Shona. So good morning. Good morning, everybody. This morning I'm going to spend a few minutes talking about supply chain opportunities with regards to the powertrain types that we deliver, which are fuel cell electric powertrains. My job role at Alkala is to head up the supply chain strategy activities, but I also look after all of our production and manufacturing day-to-day antics. So I'm going to share my screen. Hopefully you'll be able to see this. Which one are we looking at? Here we go. Great. Can you see that okay, Shona?
Yep, that's great.
Fantastic. So let's get on with this. So as Richard's talked about, we are currently in the process of a conversion. I would just like to talk a little bit about the opportunities for rail conversions as well as for new build trains, and there are slight differences it's worth considering, which will affect how potential suppliers can access the supply chain for these different kinds of implementations. So we're going to look at three main areas quickly today. We've got the supply chain for our core powertrain, which is the sort of main area that Alkala focuses on. We also, for this particular project and for future projects as well, will require general supply chain support for all your usual bits and pieces like fabrications, for support structures, wiring harnesses, pipe works, any other structural equipment, and then all the surrounding engineering that goes on with that, so things like FEA and analysis work. As well as those two, we've also got the supply chain for train retrofit, so we're talking about the actual vehicle itself, so things like inside the carriage. We might be looking at furniture and other parts of the train which are not to do with the drive. So we'll take a quick look at the core powertrain. I've got a diagram on the next slide to look at, which will help to explain a bit more. But the powertrain that we're talking about references traction motors, which are the main drives. Today, the train we're converting had previously electric drives on it. It was an electric train. We are replacing those motors with motors which are more appropriate. So I guess an important point to make here is that the high voltage levels that we talk about in fuel cells go up to about 800 volts, not 25,000 volts. And in addition, we are DC throughout the system, except for when we get to the motors. We also, in core powertrain, cover high pressure gas storage, as Richard's talked about, all of the power electronics that interlink the system, any thermal management that's required for keeping the components at the right operating temperatures, and any auxiliary drives which are for the benefit of the vehicle, so things like air system for brakes, for example. So what you see here is the main makeup of a fuel cell powertrain. It shows everything here from storage cylinders on the top left. It says hydrogen fuel tanks there. These are the cylinders that Richard was talking about. Typically, these are pressurized to 350 bar. We use a variety of options for cylinders now, which is great news for the industry. Typically used, though, in main use today are type 3 and type 4 cylinders because they're much lighter. Just below that, you can see it says fuel cell engine. This is our fuel cell module. So this module is the piece of equipment which takes the hydrogen and converts it into electricity and with heat, with typical efficiencies of around about 50 to 60%, depending upon the operating points. In the main, the power goes out to drive the system, so whether that's auxiliaries or the main drive, but we can also recover heat from this system to be able to do cabin heating, so we can increase the overall efficiency of the implementation by The high power batteries I mentioned here are for peak power. So as Richard mentioned earlier, and kind of alluded to, I guess, the opportunities for batteries and fuel cells work together, and not just in separate vehicles, but also in one application. So we have a hybrid system here. So we've got the fuel cell engine, the high power batteries, and then we have a load of power electronics equipment for inverters, for driving motors. We've got DC to DCs for auxiliary power systems, and then we have all the thermal management equipment, which is also a combination of HV powered for some of the battery cooling, but some of the air compressors, for example, may have an option to be low voltage. So I guess the messages here really are that there's a lot of opportunities for components in the system that have different voltages with different operating points. So if you are in the industry and you provide a motor, for example, just because you're working at low voltage doesn't necessarily mean that we would rule you out because we need 800 volts. So these are kind of areas for consideration as the supply chain develops. Now, we also require fabrications and ancillary, so all the basic bits and pieces like structure to support the equipment, the usual wiring harnesses. As I mentioned earlier, we don't really go above 800 volts, so I've seen some of the wires on this particular train coming off, and they're quite substantial, which is not typically the kind of wiring harnesses we use. Coolant pipe work and inlet and exhaust systems. So it's pretty standard stuff. There's nothing on here which should shock anybody. I guess I suppose that's a good point to mention, that the integration work for these systems is really, there's a lot of standard engineering. We're not developing new materials. We're not coming up with any new technology that's particularly low TRL here. This is an implementation and optimization exercise, and Alkala's value add really is in choosing the right equipment, materials, and architectures to be able to optimize the implementation. And that often means just using standard equipment that you would be able to get off the shelf. So supply chain opportunities for train conversions are pretty abundant. And you can see here, I guess this is similar to the picture that Richard showed earlier. For a train conversion, you're pretty constrained about where you put the equipment, so you're pretty much having to put it underneath the vehicle body. Really, we will try to avoid putting any equipment inside the cabin. From a safety case point of view, avoiding putting hydrogen and pipe work inside cabins with passengers is definitely something which makes our lives easier. So the preference is to put this under the vehicle. All of the other power equipment can also be slung under the vehicle, much like it is today. So we removed a number of transformers and electrical power equipment from underneath this train. We'll relocate things like air storage tanks. So in terms of engineering here, there's nothing particularly magical that we're doing. It's pretty standard fare. So I guess talking to the supply chain in that respect means that the opportunities that existed before for rail will probably continue for train conversions. There may be a slight difference between a conversion and a new build train, where I don't know if you guys are aware that the Alstom trains have hydrogen and fuel cells stored on the top of the train. They're able to do this because they have a completely blank piece of paper to start from, and the architecture can be adjusted to work in an optimal fashion for their equipment, which means they can go through tunnels. So we are, as I say, constrained to working underneath the carriages in this instance. Usual equipment still required. You know, this is still a train, still need interior furnishings and trim. So everything from seats to flooring to paint to walls, wraps, outside protection, and seals, doors and windows is something which, especially on older vehicles, will need to be updated. So we have a sort of fairly standard supply chain engagement process, but I guess one thing that we're trying to do with a lot of suppliers, so part of my activities for this project are dealing with new suppliers. We've got a number of suppliers who already work in the industry who can supply more or less what's required for these kind of implementations. We've got new entrants who want to get into rail, and as well as the old guard who are able to supply exactly what we need today for some of the existing train equipment. But part of the work we need to do, and this is for the benefit of the supply chain really, is to help describe the opportunity, because nobody in their right mind would alter a product line or create a new product or design a new service without understanding the market and opportunity. So as a business and part of my activities, I'm more than happy if you want to have a chat with me to talk about and talk through the opportunity today, and as we talked about earlier, what our future opportunity is in rail for fuel cells and well, electric drivetrains on these kind of vehicles. We'll then move on to initial discussions about high-level alignment, as well as specific normal supplier selection activities. We can then continue detailed requirements under NDA normally, and then alignment with the actual plans and activities we're undertaking. So some of the supply chain opportunities we have today are appropriate and relevant for the activity we're doing today with the conversion. But as all of the presenters have said this morning, that it's important that we look to the future. So lining up suppliers and helping them to understand what is required in the future, and for them to be able to make product decisions and investment decisions within their own businesses, something which is really important to us as a business and is important to Scotland's industry growth. So Alkala is very happy to spend the time with you guys. If you're interested to learn more, please do get in touch. I think that's all I've got today. My name is Jim Irvine, and if you need to get hold of me, the best way to do that is probably to speak to Shona.
Thanks, Jim. We're moving on now to Colin Mcelrith from MSIP. Are you there, Colin?
I am indeed, Shona, yes.
Great, thank you. Are you okay with sharing your slides, or?
Yeah, I'll share my screen. Great. And then we can share. I'll share my slides. I'm actually here. It's just that the camera doesn't pick me up unless I'm right in front of it. Okay, so I just have a few slides to go through today. So hopefully you can see that now.
Yeah, we can. Yeah. Thanks. Yeah.
So what I wanted to do today principally was talk about Locate, but I thought it was worth, because I don't know everybody obviously on the audience, I thought it was worth just a couple of slides to introduce the Michelin Scotland Innovation Park as well. So this is our site. I'll talk more about what we have on the site in a moment, but the mission that MSIP has is, as it says there, building a dynamic and creative home for innovators, manufacturers and skills leaders. And the idea that, you know, MSIP has been formed out of collaboration, so collaboration's at the heart of what we want to facilitate and nurture, and we want to have a focus. You know, our focus is around sustainable mobility and decarbonisation. So obviously, what we've heard this morning fits absolutely squarely into that focus for us. What are our ambitions? For those of you that don't know the history, MSIP was born out of the closure of the Michelin tyre manufacturing site in Dundee. So our primary goal is all around jobs and skills creation. So that's the reason why MSIP came into being, and therefore it's the reason why we're keen to focus on that. We want to have an impact regionally and hopefully nationally on the economy, and clearly sustainability and decarbonisation is the focus that we have been given and have wanted to have, and therefore our environmental contribution is close to our hearts as well. In terms of just a different view of the site and some ideas of the building blocks that we have at MSIP, it's a large site, so 32 hectares. You have a view from the northeast of the site looking down towards the Tay, so you can see that we're actually I think we're only 2.3 miles from the port of Dundee. That's a view of the site and the mix of industrial buildings and smaller buildings that we have. The red area are buildings that have already been demolished as part of the decommissioning process. We've got lots of industrial space. We're working on building an innovation campus in this central area of the site. We will have a skills academy that will be developed between Dundee and Angus College and a number of universities, including St Andrews, Abertay, Dundee, etc. And that will be located within the campus area of the site. To the north of the view that you see here, we have about approximately 10 hectares of land that is zoned for industrial development, but is currently green/brown space, so that's available for development. You can see the two obvious elements of sustainable energy on the site. We have 2 wind turbines. We have a roof to the south, which is designed for solar. And over to the west of the site, we have an energy from waste plant, which supplies via this pipeline, or will supply via that pipeline, all of the heating demands of the entire site. We also have a private wire connection to that energy from waste plant, which will go live in the near future. And we have a tenant who is looking to move into a building on the site, who are a well-known German headquartered testing and certification company, and we're hoping that they'll get the green light for their plans to move to the site and provide a testing and certification facility, which will be focused on powertrains, fuel cells, batteries, and these emerging technologies. And then also we have Locate. So now I'll talk about Locate and stop talking about MSIP. So Locate, the idea that we have developed is that Locate is it's a strategic fit for MSIP. It absolutely fits the mission that we have, and we see it as really as an anchor that will attract other industry and other opportunities to the MSIP site. So the Locate facility, Low Carbon Applications Test Centre. What we're going to cover is, what does Locate offer? There's a selection been made, or a decision been made, that we're going to focus on a powertrain test bed. So a little understanding of why have we made those choices. Talk a bit about what does the powertrain test bed look like, and then what's the initial capability for Locate. So what we're aiming to offer is a first of its kind powertrain test bed for fuel cell, hydrogen fuel cell, or battery electric drivetrains. It's part of the low carbon transport programme that Scottish Enterprise and Scottish Transport are developing. The idea that it provides an emulated response of real world duty cycles, and we're sort of focusing on heavy road vehicles, niche vehicles. And the idea behind that is that it replaces and brings forward traditional on-road testing. And it's targeted at, TRL levels of sort of 5 to 7. And very much it's unique in that it brings together all of that capability with hydrogen and power network and skills, because as you see along the top there are a number of partners to Locate, including through the University of Strathclyde, the PNDC. So there's a lot of experience that will be brought to bear to support the activity that Locate will house at MSIP. In terms of the rationale for the choice of a powertrain test bed, so it offers the opportunity to develop individual systems. It offers the opportunity to develop subsystems and components, either in isolation or as a complete package. So it allows the opportunity to test the entirety of the package, or once you have a package that's already developed, it allows you to swap in and out components and see how the performance of the overall package changes as a result. It allows you to do model in loop, hardware in loop test packages, and it gives the sort of opportunity to relatively uniquely test and develop the system interactions and the software packages alongside the hardware. So it really is trying to provide that holistic envelope and ability to package, to test. What we believe is that it will significantly reduce the need to perform on-road testing, because all of the kind of duty cycles, drive cycles, the routes, the climatic conditions, etc., can all be replicated within that test bed. So the idea is that you can capture a lot of data from real world ICE vehicles today, and you can plug that data and that modeling capability into the test bed and replicate that real world data and real world experience with the test bed, and thus avoid the need to go out on the road with mules, etc. Tests that would typically be performed later on the finished product can be simulated, so we can look forward to say, well, once we had a rolling chassis, we would put it out and do X, Y, and Z, or once we had this, we would go out on the road. We can simulate those and bring them forward earlier in the development cycle, in the product development cycle, and that allows you to adapt the design and the project scope much earlier in the journey. And similarly, we can look at things like the fuel economy of the vehicle over a predefined route, how much hydrogen storage is needed, and what consumption, to cope with the consumption requirements, and just simply things like the range, the impact of climatic conditions. So very strongly, we believe that a powertrain test bed provides the best opportunity to provide real world accessible testing for vehicles and products as they develop through their development journey. What does a typical test bed look like? So there's an example there from Millbrook. So as you would expect, dynamometers, battery emulators, a power supply, data acquisition, etc., measuring torque and power, and then the idea is that there's the capability of building the. Sorry, is there somebody can go on mute?
Hi everyone. There just seems to be a wee bit of background noise. Are you okay, Colin? Colin, you've gone on to mute.
Gosh, that was me. Sorry, guys. I muted Colin by mistake. I tried to mute the wrong person. Sorry about that, Colin.
That's
No
okay.
problem.
No problems. Can you hear me now? Yeah?
Yes.
Yes. Okay, that's fine. I'll continue. So typically within the test bed, all of the equipment that you see there, and the idea is that this facility will have the space for the kind of preparation area for the rolling chassis or the equipment offline, moving it onto the test bed to allow the test bed the testing program and regime to be followed, and then move it offline again to allow somebody else. So the idea is that we aim for high utilization of the test bed where the majority of our equipment and capital outlay is tied up. The initial capability that we're targeting at the moment is that it is only for zero emission vehicles. So there's no internal combustion engine capability. We're not planning to have any liquid fuel on site, so we don't have the ATEX requirements that go with that. We're not anticipating having any emissions measurements capability either. So it does very much simplify it and allow us to focus very much on the zero emissions vehicle market. Initially, we'll have a single test cell with two-wheel drive and approximately 400 kilowatts per wheel, which is large enough for a bus chassis. The vehicle that we're looking at the building that we're looking at for Locate will easily accommodate a bus or other typical heavy goods vehicles, potentially even agriculture or mining equipment. And the future ability, so the intention is that as Locate gains its feet and starts to operate, we'll look to develop towards 4 or even 6-wheel drive. The sense is that we'll have the ability to emulate offtake loads for example, refuse collection vehicles or other vehicles with auxiliary power requirements. As I said earlier, 2 prep areas for test pieces. There'll be a workshop and there'll be support on site from that point of view. We'll be able to lift and move things around, and then all of the sort of office space and sort of welfare and IT network with appropriate security. It's possibly worth just sort of stating that the entire MSIP site is a secure site. So we have a 24/7 secure site at MSIP, and Locate will be located on the secure side of that site. Equally, at MSIP, we will have a hydrogen refueling station, which will be powered by our 2 wind turbines and in time by the solar array on the roof of our warehouse. So the sense is that not only are we developing zero emissions vehicles, the hydrogen that we'll be using to do that development work will also come from zero emissions sources. Okay. Any questions on that?
Thanks very much. That was great, Colin. There's some questions that we've not answered before, so I'm just going to run through them if that's all right. So it might include some of the speakers from previous presentations too. John Campbell asks, can the speakers offer any insight into the origination of the hydrogen fuel, the storage, logistics, etc., to support a hydrogen fleet? And on a similar note, Nick Stapley, who's actually one of our SMEs in the cluster builder from Logan Energy, asks, as a Scottish SME, we'd be very interested in understanding how we can get involved in the provision of hydrogen and refuelling infrastructure for trains. Are there companies we can engage with on this aspect? Thank you. Would anyone like to go first?
Maybe I should tackle that one. Essentially, well, let's start off anyway. We're very keen to, as far as possible, create green hydrogen infrastructure for the zero emission train. And obviously we want to use renewable power from the excellent renewable power sources in Scotland for that. And it's basically a wide open opportunity there to get involved in the provision of that. There are a number of parties who've been involved in such projects already in Scotland, but all these things will be going out to full open procurement. So there's plenty of opportunity to be involved in that space. And if there's any part of it that involves testing some subsystem or something like that, that ecosystem that I described before could be an excellent way to do some of the de-risking with other funded projects that could be out there to help you with that. So that's hopefully tackling that. Maybe any of the others want to add anything?
Yeah, perhaps. I mean, Jerry mentioned that there's some news we're hoping to announce coming shortly about further additions to the current project, and particularly that's looking at exploring the routes to getting the hydrogen infrastructure to align with the train refueling. Because yes, it's a really key part of what does this look like in the depot, and how do we add that perspective to not just the train development, but the practicalities of refueling. So yeah, look, there's more going on that work. It's a key thing that needs to be done next, I would say, in terms of the rollout of hydrogen on the railway. And we're hoping to have some progress on that. And I think to Nick's point and question, this will be the world of the operators and the Roscoes, I think, in terms of who the players are looking at putting the infrastructure in place alongside the network in depots or where else. And I give you a sense of the scale we're looking at as well to bear in mind. the Far North Line, the requirement for the current service, never mind extending it to extra trains, it's about a ton of hydrogen a day. So just a useful picture in terms of what the requirements are for everybody on that side.
Can I just jump in just to say that for Nick, we're actually engaging with the Roscoes through the Rail Cluster Builder project, so we'd be delighted to connect you if that would be of use. We'll get in touch with you separately on that one. Does anyone else have anything for that question? No. The next question is from Ian Ray. I don't know if Ian, you want to ask your question or I'll do it for you. If you're still here, I think you're here.
Yes, still here, Shona, if you can hear me.
Yes, I can, yeah.
No, thank you for the opportunity to ask a question. I'm just wondering, in terms of the kit, in terms of for modelling the various engines or transmissions on it was the APTTB, does that allow to simulate regeneration? I'm very conscious in a rail vehicle, we've got maybe 25-30 tonnes of kinetic energy stored in that vehicle that we'd like to regen back into the batteries. I'm just wondering what your kit has a capability of simulating that. So you almost need to actually power, almost reverse power into the power cell you've got there. I don't know if I've made sense in that question.
No, it makes complete sense, Ian. I'll give you my understanding, and possibly it's worth. We don't have the technical guys from Locate, and Richard's putting his hand up to offer to help as well.
Yeah, I'll help as well.
And Jerry will jump in as well. So I'll possibly shut up and let those guys answer, and then if there's anything else, you can come back to me, because they know more about it than I do, I think would be fair to say.
So Richard, you want to tackle the drivetrain, and I'll tackle what's planned for Locate.
Yeah, sure. So I mean, from Alkala's point of view, looking at putting our powertrain systems into test, this is a key requirement for us that we fed into the requirements for Locate. Yes, understanding the efficiency of the whole system as it runs in an operation on a vehicle without having to test the vehicle on the road. So yes, simulating regenerative braking, simulating the traction performance of a motor, and then all the way through battery, fuel cell, and use of hydrogen is key for us to prove out our systems. Okay.
And then in regard to Locate, the tech spec and functional requirement for Locate as they stand today, and they're not likely to change very much. Basically, describe a facility that would allow you to do exactly that. That's a key part of a mission. And so that's definitely doable. The one slight caveat is that today, in order to hit the budget, is a two-wheel facility, which we did not plan in directly the rail capability on day one. But since doing that, since we wrote the tech spec and functional requirement, we realized that the specifics of the trains that are likely to be converted and tested in the near term might allow that to be used in the original spec. There's just basically one small gearbox missing that's actually a production item. It's not a one-off. So it could be that we could be doing rail sooner than was originally planned on Locate, but certainly regeneration is a key part of the functionality that we tested in over a full mission.
Well, that'd be excellent. I think a key part of that, because it's about how the system operates as a whole, and really understanding how much regen you'll actually get back. Yeah, obviously real life will always be a wee bit different. It will be different, but at least gives you a good starting point to what it should be. Thank you for answering that.
Great stuff. I think this is our final question. It's from Rob Hogg. I don't know if he's still on the call or wants to ask his question. I can do it for you, but if you're still there, give him a wee minute. No, I'll just ask. What are the views of the Roscoes and OEMs on retrofit to legacy vehicles? Sorry, Rob, is that you coming in now? Sorry.
I was fighting with the mute button.
Don't worry.
Given that you're highlighting the legacy vehicles and the 72 vehicles in that, with OEMs, how are they taking the view of retrofitting some of theirs, and what is the feedback from them on that in terms of timescales?
So perhaps I'll take that from Alkala's point of view. So I think the OEMs, I'm fairly sure that their preference is to do new build. That's their business model largely. On the other hand, if you look at the Alstom Breeze project, which is something that's going to be developed, I think, in St Helens for lines in north of England initially, that is a repowering of one of their own rolling stock. So yes, they're looking at it, exploring it, but I'm sure they would imagine they would like the larger long-term opportunities for new build trains and the optimization that you can do around a powertrain of a new build vehicle. In terms of the Roscoes, I think they will take a very similar position to Bill, as it'll be about the business case and the overall economics of a repower versus procuring a new train, and that will align very closely with the requirements of the rail network and the integration of the vehicles to do the plan for decarbonisation as that rolls out over time.
Richard, if you want, I could add to that as well, if that's okay. Just from a Roscoe point of view, obviously ERG are partnering Alstom, and you're right, for the Breeze conversions, that's converting maybe a 25-year-old EMU to a hydrogen train. Porterbrook's put significant investment of converting EMU vehicles to hydrogen trains as well. And Angel's done a lot of investment on their HyDrive, which is a DMU traction battery conversion. So that's similar. So there, certainly, like all Roscoes, it's about the pounds, shillings, and pence, and extending the life of their asset. So yeah, if it makes money, makes business sense, the answer is always yes. From a Roscoe point of view.
I think I'd come in and building on what Ian's just said, there is clearly an interest in the supply market, particularly those who already own vehicles, for re-engineering. For ourselves, we've got to do two things. We've got to get to a net carbon zero railway, and we've got to reduce the net cost of the railway. And that means driving down the unit cost of rolling stock delivery and operation, and driving up the revenue we secure from that rolling stock. So we do not have any prejudice about new versus old. We are really interested in the economics of the proposition. And if you start with an awful lot of asset, it ought to be possible, oughtn't it, to offer a good value for money solution. So I see the market working well in terms of this opportunity.
I just add to that, to what Bill says there, that the opportunity to work with repurposing vehicles in the early stages buys time for an OEM to essentially do a cost-effective conversion, not something done under duress and pressure. So there's a nice organic feel to this. Essentially, it makes a lot of sense to try and use the existing fleet to start with, and then as time moves on, you bring on board the OEM equipment, which has had the time to be matured properly and can then be bid at a sensible cost.
Maybe just add a little bit more onto that. Obviously, the potential cost benefit, but there should be a carbon benefit of this as well. The fact that you're reusing a vehicle structure, reusing seats, reusing probably 80% of this vehicle, and only putting 20% new stuff on. If you both cost in terms of what's the cost benefit, but it should also be what is the carbon benefit. We are trying to decarbonise railway, and not just operations of it, but we should be thinking about the carbon effect of our capital costs as well.
Great stuff. I think we're just about approaching 12 o'clock. I've got a very quick question, if you don't mind, of my own. Jerry, you mentioned your offer of help to the Scottish supply chain through the Hydrogen Accelerator. How would suppliers get in touch with you?
Yeah, the Hydrogen Accelerator has got a website which you can easily find through Google, and you'll find contact information there. There's a Hydrogen Accelerator email there that you can email into. So I would suggest just Google Hydrogen Accelerator, and send us a message, and we'll try and find a way to help you.
Brilliant. Thanks very much. That's great. I think that concludes today's session. I just want to thank everybody very much for attending, and a special thank you to the speakers, Bill, Jerry, Richard, Jim and Colin. Your presentations were great, and we're really grateful for the input this morning. We'll be announcing, just for Rail Cluster Builder members, we'll be announcing a Skills Development Scotland event shortly, so keep a lookout for that. And thank you very much for joining, and enjoy the rest of your Wednesday. Thank you. Bye.
Thanks all. Bye.